All right, well, we're going to start graphing parabolas in this lesson. We covered parabolas in chapter 4, so you already know a lot about them. Some of this is going to sound familiar, and then we're going to kind of add on to it here in this lesson. So let's just review what we already do know. The parabolas that we dealt with in chapter 4 followed the quadratic formula, which you see right here that I've written down. We know that based on the a, so the lead coefficient, on the x squared term, we can determine whether the parabola opens up or down. So if the a was less than 0, then we knew it was going to open down. If it was greater than 0, we knew it would open up. Okay, the axis of symmetry. So that was the line that ran up and down through the parabola and through the vertex and cut the parabola in half in mirror images. So that was our axis of symmetry, and we were able to find the x coordinate for that by taking the opposite of our b, which we got it from our original equation, and putting that over 2 times the a value in the original equation. So by following that formula, we were able to find the axis of symmetry, which also gave us the x coordinate for the vertex. So the vertex was either the topmost point or the bottommost point on, depending on how it opened, up or down, of our parabola. All right, and then once we had the x coordinate, we were able to take the x coordinate, evaluate it back up into our original equation, and that gave us the y coordinate, which is why I have a question mark here, because we have to find our x here through this process over here with this formula, and then evaluate back in to get our y. All right, so that's all review. What we're going to do that's new in this chapter is talk about parabolas that open left and right. So they're going to have the same U shape. They're just going to be opening left and right instead of up and down. The axis of symmetry is also going to change. The ones that we're going to talk about in this chapter are all going to have a vertex at the origin. So their vertex is going to be sitting right here, at the origin. And so if it's sitting at the origin, which I don't have the left one quite on the origin, but the right one here is a better example. You can see that the axis of symmetry is not going to be the y-axis. It's actually going to be the x-axis. So if I run a line down between here and here are my vertex on this parabola, then this right here is my axis of symmetry. It's cutting that in half. So my axis of symmetry is changing as well. It's going to be the x-axis instead of the y-axis. All right. Note that these are not functions. They do not pass the vertical line test. So if I have this one right here and run a pen down from the top to the bottom, I'm going to touch the graph twice, which means it doesn't pass that vertical line test, so it's not a function. Now, the standard form on this type of parabola that opens left and right is different than the standard form for the parabolas up here that are quadratic and open up and down. The standard form, if they open left and right, is that I'm going to have a y squared. So it's going to be y squared equals x. And actually, I left my a out here. I should have an a in there. Y squared equals a times x. Up here in our quadratic, the standard form, one that has a vertex of at the origin, all right, would look like this. So my standard form for my parabolas that open up and down has this x that's raised to the second power. Opening left and right has the y that's opening to the second power. So that's the difference, and that's why the graph is going to change directions. Okay, now a couple more vocabulary words before we get started on the problems. We have a new vocabulary word called the focus, which is a special point on the inside of the parabola. So it's going to actually be inside the U shape. And then you have a vocabulary word called the directrix, which is a line, a special line, represented in this green right here, outside of the parabola. So the focus is inside the parabola, the directrix is outside of the parabola, and most importantly, it is perpendicular to the axis of symmetry. So in this particular case, the vertex is sitting at the origin, and so my axis of symmetry is the x-axis. It's x equals 0. That's the line that's going to split that parabola into its mirror images. So the focus is on the inside of the parabola sitting on that axis of symmetry. It has to be on the axis. And then the directrix is perpendicular to the axis of symmetry. Okay, so now let's talk about the steps that we need to follow to actually graph these parabolas. So steps to graph. The first thing we have to do is look at the equation that we have and determine what is squared. Okay, so look at the equation, what is squared. So once we've determined that, we're going to know whether it opens up or down, left or right. So if it's x squared, which is what we have been dealing with in the past, that's our quadratics we used in chapter 4. If it's x squared, then it's going to open either up or down. If it's y squared, then we know it's going to open left or right. Okay, so that's the first thing we want to do. If I look up here then at 1, 2, and 3, I can determine at least whether it's going to open up or down, left or right. So for number 1, my x is squared, so I know I'm either going to open up or down. Number 2, my y is squared, so it's either left or right. And same thing on number 3. The y is squared, so it's going to be left or right. So we've narrowed it down at least. Now, what we have to do to actually decide which one it is put it, first of all, make sure that the equation is in the form either x squared equals something or y squared equals something. So let's say put the equation in either x squared equals or y squared equals. So basically what we're trying to do here in this step is isolate the term that is squared. Okay, and then we have to calculate something called that we notate with the letter p. All right, so we're going to calculate p, and I'll show you how to do that in a second here. Okay, we're going to have two equations that we use based on whether we have an x squared or a y squared, but they're very similar. And this is another form of these equations when we're talking about standard form. So if your x is the squared term, then the other form that we can write it in is x squared equals 4py. So this is the p that I'm mentioning here that we need to be able to calculate. If our y is the variable that's squared, then the standard form will look like this: y squared equals 4px. It's just another way that we can write these equations. All right, so in number 1 up here, we're going to need to use this first equation, this first standard form, in order to calculate p. Okay, so let me write, I'm going to expand this a little bit, and I'm going to take the standard form for the x squared down here, and I'm going to write it underneath our problem up here, just so you can see what the 4p is going to be equal to. So my x squares match up, my y's match up, so my 4p I can actually say set equal to that -4, that coefficient. So I can say 4p equals -4. And then if I solve for p, I get p of -1. If we end up with a p value that is less than 0, then we know that our parabola is going to open down. Okay, so we're going to say we narrowed it down between up and down. We calculated our p. Our p is less than 0, so we know it's going to actually open down. I can do the same thing on number 2, except now I'm going to use the y squared equals 4px. So y squared equals 4px. This is just the standard form. So once again, I can see my y squareds match, my x squared. My 4p actually is equal to that 7 there. So 4p equals 7. My p is going to come out to be 7/4. This is greater than 1. So because it's greater than 1, this one is going to open to the right. Okay, so towards the positive side. That's one way you can remember it. Is if p is greater than 0, it's going to be positive and it's going to open right towards the positive side of the x-axis. So y squared in number 3 equals negative 2x. So that means that my 4p equals negative 2 on this one. And when I calculate that, I'll end up with negative 1/2. So on this one, p is less than 0. That means it's going to open to the left. All right, so we're going to use the y squared or x squared to narrow down whether it's up or down, left or right. Then we actually calculate p to see to narrow down to the final answer. All right, so let me write that down in a step. After you've calculated the variable p, if it is greater than 0, then it's either going to open up or to the right. So that depends on whether you had an x squared or a y squared, which you determined in step 3. If p is less than 0, then it's either going to open down or to the left. All right, after we do all that, then we're going to do some calculations to actually graph them on 4 through 6. All right, so looking at number 4, I have an x squared. So that means, according to step 1, that my graph is going to either open up or down. All right, so up or down. I'm going to use the equation is, according to step 2, the equation is in x squared equals terms. So the x squared is isolated by itself on the left-hand side there. So now I'm going to calculate p, and I'm going to use the x squared equals 4py form of the standard equation. All right, so if I write that under there again, and I'm just writing this so you can kind of see how that 4p is the thing that lines up with the coefficient of 12. So if I take the 4p and set it equal to 12, I'm going to get a value of 3. All right, so the value of the variable is greater than 0. So because of that, I know that this is going to open up instead of down. Okay, so I can expect that. All right, so when I make an XY table, I can see that when I plug in 0 for y, so I'm going to plug it in for y because it's going to be a little bit easier to calculate. I'm going to get an x of 0. So that just confirms that our vertex is on the origin. And then I'm going to look for a value of y that when I multiply it by 12, I'm going to get a perfect square. So in this case, if I multiply 12 by 3, so I take a value of 3 for y, I'm going to get 36. If I take the square root of 36, that gives me an x of 6. So I'll come over here at 3, 6. Oh, I'm sorry, 6, 3. Okay. And now to get the other point, this is a parabola. So the axis of symmetry, in this case, because it's opening up and it's an x squared, our axis of symmetry is the y axis right here at x equals 0. So that means that I can find a third point just by mirroring it over here to -6, 3. And so that's how I can get that third point. All right, and then just connect those with a curved line. And so now the last thing we need to do is identify the focus and the directrix, like they ask us in the directions. So this is where the value for p really comes into play, because the value for p, remember, if you go back to the definition, I said that the value that the focus has to lie on the axis of symmetry. So this P right here is giving us the point where the focus is going to be placed on the axis of symmetry. So if my axis of symmetry, like we said before, is right here on the y-axis at x equals 0, then my focus is going to be right here at the point 0, comma 3. Okay, now the directrix is outside the parabola going the other direction, and that's the line that's going to run perpendicular to the axis of symmetry. And the directrix is going to be exactly the same distance away from the vertex as the focus is. It's just going to be going in the opposite direction. So while the focus is at 0, 3, the directrix is going to run through -3 because we want it to be equidistant, equal distances from the vertex. Okay, so wherever the focus is, the directrix is going to be the same distance outside of the parabola, and it's going to run perpendicular to the axis of symmetry. All right, we'll do the same thing with number 5. We'll determine what's squared. In this case, it's y squared, so we know this is either going to open left or right. We're going to be making sure that the y squared is isolated in step 2, which it is already. And now we're going to calculate p. So we're going to set -4. We're going to use this equation right here, this y squared equals 4px. So we're going to set 4p equal to that coefficient of -4. And then we'll solve for p and we'll get -1. Since p is less than 0, we know that it is going to open to the left instead of to the right. Okay, so we've determined all of that. And now we're going to make a table. We can see really quickly again that if I plug in 0 for x, I'm going to get 0 for y. So our vertex is at the origin. And then I'm going to do the same thing where I'm going to multiply by something that will give me an easy square root. So if I multiply by -4, sorry about that, that will give me a -16 here. I'm sorry, a +16, and then the square root of that will give me a 4 for my y. So that's a really easy point to find. All right, so that will be at -4 and +4. So we're talking about right here. Because this is opening to the left, then we know, and it's a y squared, we know the axis of symmetry is going to be the x-axis right here. So that's our axis of symmetry. So this is our mirror. So I'm going to mirror that over to get the third point. And then I'll draw my parabola in like that. Now, the focus again now is going to be on the inside of the parabola, and it's going to sit on the axis of symmetry, and in this case it's going to be a -1. So I'm going to locate that right there at -1, and then my directrix is going to be outside of it, a perpendicular line perpendicular to the axis of symmetry, which is sitting here on the x-axis, and it's going to be equal distances from the vertex. So the directrix will be sitting at x of +1. All right, and then last one, we have an x squared. So we know this is going to be opening either up or down. I'm going to use this equation now, the x squared equals 4py. And so I can see that I'm going to set my 4p is going to be equal to this -1, the -1 coefficient that's on the y. I'll get a p of -1/4, which is less than 0. So this parabola is going to be opening down. And then I'm going to make a table. Again, plugging in 0 for my x, I'm going to get, or I'm sorry, for my y, no, I didn't, I said that right. For my x, I'm going to get a y of 0. So again, going to be at the vertex for our origin. And then if I plug in 1 for y for x, I'll get -1 out for y. So that's easy. This is going to be opening down. So my axis of symmetry is going to be the y-axis. There's the first point, and then when I mirror over the y-axis, it'll look like that. Connect those in a smooth curved line. And then the focus, again, is at the p of -1/4. So I'm going to try to get that. It's not too far from the vertex. So there's your focus, and then the directrix will be opposite of that, equidistant. So it's going to be +1/4 right there on the other side, on the outside of the parabola. Okay, well, on the back, they ask us to write the standard form of the equation of the parabola, and they have given us the focus, and we are to assume the vertex is at 0, 0. So that means that we can use one of these two forms over here, either the x squared equals 4py or the y squared equals 4px. So what we have to determine is based on the focus they gave us, that's all they gave us was the focus. We have to determine first which one of these equations we need to use. So that's step one. If you like to write your steps down, that's step one. When they've given us just the focus, then we need to use that to figure out which equation we're going to use for standard form. So if I'm looking at number 10, I can see that my p-value, because remember that's how we determined the focus in the problems before, was the p-value. I can see that my p-value is the x-coordinate. So when they figured out and they calculated p in this particular problem, they got a value of 2, and that correlates to the x-coordinate here. So if you look over here at my graphs that I've shown you, if I have a p value as the x-coordinate, it has to be either one of these two graphs on the bottom, because when we have a parabola that opens left or right, that's when the focus is on the x-axis. All right, well, because 2, 0, that is on the x-axis. All right, so I know that I need to get this equation into the form y squared equals 4px. All right, let's do that again with 11, and then we'll come back and actually solve these. So in number 11, I can see that my p-value was at 1. All right, so that means that my focus here on this particular problem is on the y-axis. Okay, right here it's either opening up or down. We don't know that yet. We don't know the direction yet. But we'll talk about that in just a moment. All right, so because of that, I know I'm going to use this equation right here. All right, and then the same thing for number 12. I can see that when they calculated p for this particular problem, it ended up being on the x-axis at -1. So that means I'm dealing with one of these two equations down here. I'm sorry, one of these two graphs, which means I need the y squared equation. All right, so we've at least narrowed that down. And so now we can go back and do a little bit more investigating, and we can determine, like in number 10, and we don't need this to actually write the standard form of the equation. However, it's good to talk about it. Since our p-value here is greater than 0, p is greater than 0 in this problem, and we're talking about the y squared version of the standard form, that means that this particular graph in number 10, if we were to graph it, we're not going to, but if we were, it would open to the right. In number 11, we have an x squared, and we can see that our p-value is greater than 1. So because our p-value is greater than 1, and we're talking about an up or down parabola, this one's going to open up. And then similarly over here in number 12, we have a negative p-value. We have a y squared version of the function, and so it's going to be one of these two down here. The one that corresponds to a negative p-value is the one that opens to the left. So we could determine a little bit more about these just from being given the focus, but we don't need that to actually to find the standard form of the equation. But I just wanted to point that out to you just so we can kind of, the more dots we can connect on this, the more understanding you're going to have just kind of overall the whole concept. All right, so now this, we did the hard part. Now this is easy actually to finish it up. I'm going to just take that p-value and plug it in to the equation. And I'll end up with y squared equals 8x. This is the standard form. We want to leave y and x open. So we were just trying to calculate p, and that's it. And then we're going to leave y and x open so that we could actually make an xy table if we were asked and graph this. Same thing here. Plug in 1 for p. And our standard form for our equation would be x squared equals 4x. Leave the y. Whoops, this is supposed to be a y. Hang on, I have one little error here. Okay, this should be y. Y right there. I just put an x out of habit. And here, if we put negative 1 in here for p, we'll get negative 4x. Okay, so that's it. The hard part here is just determining which equation we need to use based on that focus. So if you have this written down, what I have on the screen here on the right hand side, you can use that. This is also in the book on page 620. So if you'd rather refer to what they've got on 620 in the book, you could do that as well. So we need to add one more thing on to our graphs over here to complete 16 and 17. And this will be the last new idea for this lesson. I'm going to erase these constrictions on P so I have room to talk about the directrix on each of these. The directrix, remember, is the line that's perpendicular to the axis of symmetry. So right here I've got my axis of symmetry as the y-axis. My directrix is going to be the opposite direction of the focus, but the same number of units. Okay, so my directrix is going to be about down here, and it's going to be the same distance from the vertex. Remember, we're taking everything, the vertex is the point that we're referring to. So if from this vertex I go up p units to the focus here, that means to go down to the directrix, I go the opposite of p, this direction. Okay, so in this particular graph, my directrix is going to have an equation of y equals the opposite of p, right? So this, because this is the y, these are our y coordinates, it's a line running through the y coordinate that is the opposite of p. Up here in this one, I'm talking again about the vertex. Here's my point of reference. If I had to go this direction to my focus, then this particular one is going to be up here in this quadrant, but it's still going to be the opposite of whatever p was. Okay? We're talking about just like the number of units away from the vertex. On the bottom two, so our y squareds, they're going to actually run through an x coordinate. So this is going to be a vertical line through an x coordinate, but we have the same scenario presenting itself. So here's my vertex, it's p units this direction. My directrix is going to be p units the opposite way. But this time it's going to run through an x, whatever that x coordinate was. So this will be x equals the opposite of p. Same thing on this side. Vertex is my reference point. I'm going to go the opposite direction. It's still going to run through an x. And so x is going to equal the opposite of p in this case as well. So when we have to write the standard form of the equation, according to number 16 of the parabola, but this time they gave us the directrix. So in 10, 11, and 12, they gave us the focus. And now they're giving us the directrix. And so in order to start this, the first step is to look and see if my directrix is an equation at x equals or y equals. So number 16, it's at x equals. So that means I'm talking about one of these two equations right here. It's either opening left or right. So that lets me know that I'm going to be using the y squared version of the standard form. Okay, the only thing, now that I've determined that, now all I need is to know the value of p to finish off standard form. Okay, if my directrix was at x of 3, that means it looks like this one on the right here. My directrix is on the positive side of the x-axis. Then my focus, which is what I need, all right, because remember, this is the opposite of p. I want p. So I'm going to take the opposite of it. I'm going to go the opposite direction. If my focus was 3, I'm sorry, my directrix is at x of 3, then my focus is at x of negative 3. And so that is the value for p that I'm going to plug in. Negative 3, that's supposed to say. Leave my x, and that's my finishing that off. So that means I have a y squared equals negative 12x. This is my standard form of the equation. I'm going to leave it like that with x and y open so I could graph it with a table if I were asked to. All right, so 17, we have a different situation where now we have our directrix at y equals negative 2. So if it's at y equals, then I'm talking about this one right here. So y equals negative 2 shows this situation right here where my directrix is down here in the lower two quadrants. All right, so if my directrix is down here at negative 2, that means my focus, my p-value, is at 2. It went the opposite way into the positive. I'm going to use this equation right here. X squared equals 4 times 2y. And so my standard form becomes x squared equals 8y.